Civil engineering is a very broad subject and it encompasses right from infrastructure to buildings to roads to oil and gas, you name it. So it's a brick and mortar type of profession which everybody, whether it's an IT or it's a hospital or a medical, needs a civil engineer. Now, civil engineer per se means basically you are into construction or you're into design. Now, in design, there are aspects where the structural civil engineer comes in. So, structural engineering is an offshoot of civil engineering, which deals with design mainly and erection. There are some civil engineers, structural engineers who do engineering, procurement and construction. So, they do the detailed design, they do the procurement and the construction. So, it's a very, very wide range of work or profession where you can get your niche and get involved in. What we find is that the civil engineers who come out are looking for not to do design. The design part, which is a tough part, structural engineering, it takes a little bit of person having to like a lot of things in computers, a lot of things in different parts. So now if that is not there, they go into the field. So that field part of it is more interesting to these guys because they actually see it happening. We see it on paper and then we see it on happening, right? So when the guy is in college, if he's taken civil engineering, the student has taken civil, and the subjects he likes in civil engineering. So he's going to learn in the first year, he's going to learn a little bit of mechanical, electrical, civil, all fields. That's how it works. At that point in time, say he selected okay and now he's taken the civil engineering. Now in the civil engineering, there is maths, there is statistics, there is computers, computer aided design. So now different subjects are there. So from the subjects he likes, he should really understand that yeah, I enjoy this. That's the point he will come to saying that I want to go into design. Once he goes into design, it's structural engineering. So he has to get into the design part. Because first is the design, the know-how of the design, and then going to the site and field. So you do design, you go to the field, take experience in the field, and then go back to real design. So then you learn both. You learn how to design to suit construction, to suit to build. So you don't design something and say, okay, now you build it, because then it's never going to happen, because it's impractical. It's very difficult for it to happen. There are many verticals in our organization, like you said. So the infrastructure department has an infrastructure design team, drafting team, admin team, quantity surveying team, because they got to take out estimates. So this is the normal trend in all the verticals. So if in the structural steel design, so the steel designers will be in the concrete design again. So now what happens is that what we have done, we have segregated infrastructure. We've got a repair department that repairs and does heritage, like this Zara building. We have a design infrastructure, and the rest of the design, we've got associates. So like there are design associates, so like you come up the hierarchy. So you start as a junior engineer, then a senior engineer, junior associate, senior associate, and then the associate. So these are the roles, and then there are draftsmen. And then we have an entire quantity surveying team, which is separate, which does calculations on costing, on people giving them feedback, yeah, this design is right, wrong. So they do value engineering, and then they do tendering. So there is a tendering, calling for estimates, doing that. So that's how the whole gameplay plays. Yeah. Architect basically has a role of planning, like the plan, the layout, the flow of the movement and the usage, how to use space, creates it. Now he needs to execute it. So he needs a structural engineer and he needs a MEP, like a mechanical, electrical and plumbing engineers to come in to actually make it strong, to resist earthquake, wind, the forces of nature, and to take care of the loads that you will be imposing on the structure. So depending on what it is, that's where the structural engineer comes, and he joins the architect to create the form which is feasible. So today, very unique buildings are coming, very high rise. Supposing the Burj now is the highest, right? So there, the whole design was controlled by a structural engineer. The architect could not form the building because it had to withstand high rise wind speeds at 800 kilometers, at 800 meters. You have to withstand high wind speeds, you have to withstand earthquakes also, and you have to withstand dust storms and hot and cold. So there the structural engineers ruled the design, right? And they sort of handheld the architect and say, okay, you can do this. Then the guy added the glass and the stainless steel and everything. Whereas in the normal buildings, a little shorter, smaller buildings, the architect will say, I want a real form like this. Then the structural engineer has to rack his brains and find out how he is going to make that form happen. So that's the difference. Ideal engineers are very, very qualified. I think basically the ability, the only reason why what really does when you go abroad and you learn there, you're out of a shelter. So the education is pretty much there. It's there the same. But because you're in an environment like when you're in a boarding school, you're in an environment where you got to fend for your own. So when you go abroad, you learn to fend for yourself. You learn to manage your finances. You learn to manage yourself. That is the biggest part of learning which you have over there. Over and above, of course, the quality of education has differences. I'm not saying there are no differences, because there you get taught by the American code. So the American code you learn. Here you would come back and learn the IS code again. So you have to be attuned to take care of that, because you have to work with the law of the land. You can't say I've done American code, therefore you'll apply it in India. Though when the IS codes are silent, then you use references from the American code. That's the advantage that you get. And internationally, American codes are recognized all over the world, whether it's the Middle East, Saudi Arabia, whether Israel or in Australia. Aussies have their own code, but if you're saying the ACI code, if you get your certification, which is a licensed engineer, that's not recognized from America to here or India to there. So it doesn't matter. But if you have a license here and you're an Indian Institution of Engineers member, it makes a difference to us, because then we know that you understand responsibility. Basically, a B.Ed or a B.Tech design, or M.Ed or M.Tech, depending on which university they come in from. We normally prefer taking master's students because they understand a little bit more of structural engineering, though we've got guys who are undergrads. So if a fresher is there, generally as a fresher, master's is preferable because he is there. And with a B.Tech or B.Ed, we take people with 5 to 7 years experience minimum who have worked elsewhere. So that because we need to actually inculcate them into our culture. So you need to have a little bit basic tools of design, like knowing a ETAP software or STAAD software or SAFE, or certain softwares are there which help, tools, and you have to have a little, and then we have internal tests. So we do tests, and then depending on the ability and the IQ, we pick that candidate. That's how we do it. There's a whole complex which we designed. It's a unique complex, the Powai complex for the Hiranandanis, which is there. That entire complex is done by us. So right from the start in 79 and in 80, I was appointed by the Hiranandani brothers, and we have been since then doing all their work all over the country. So we've done the Powai, we did the Thana, we've done the Chennai, we've done the Bangalore. But the unique part of Powai was, at that time, people had in Mumbai city never heard about having concrete roads, never had. So we did a lot of firsts. Okay, so like originally building construction in Mumbai and in India was a very volumetric based cement consumption design. So at that point in time, they came up and said that we don't want buildings to crack and leak. So the buildings that we built from day one, we upgraded the concrete strength. We changed the specification, and these brothers backed us because it costs more. It cost more at that time than the construction costs that were there, which they said yes, they spent that money, they took it, and we created genuinely leak-proof buildings. The buildings don't leak. They've not leaked till now, and they don't leak. So they were the first at that time. In 1983, we laid concrete roads, where everyone was still doing tar roads. So we had to repair the roads. Even today, star roads of BMC are being repaired. These roads are not repaired since 1982, not repaired at all. And there are very unique buildings. There's a Lake Castle, which was a 600 feet long building. First high-rise building in India in 1994 at Breach Candy. That was a 44-storied building opposite the US Consulate, then US Consulate, which is called the Suraj, which was now called the Millennium Tower. Now recently we've done a very unique building called the Capital, which is a commercial building in the BKC. Bandra Kurla complex, that's the one with the circle. Yeah, even the Wankhede Stadium was our project, which is the new Wankhede Stadium, which is a very unique thing because it's a 30-meter cantilever. We prefer having students who have done higher upgradation of software, like I said, e-tabs and all, but there are softwares like some who are like 5-7 years who have done Rhino and all. So if you want to do a algorithm design and you want to create different shapes, so there's a different set of software. And that is known internationally, what these softwares are. But you won't learn that in college. Right? That comes when you come in with us. Then you'll end up getting exposed. So we would prefer that after you have done your college or whatever study or formal education, after that when you're doing your internship or you're working somewhere, because we tend to take only people with some experience, one should start looking into this. Like e-tabs is a definite requirement, STAD would be another requirement, SAFE would be another requirement. So these are the softwares and you should understand and read up on wind tunnel studies. What are they? Earthquake studies, what are they? There's a different method of doing an analysis called a non-linear analysis. It would be a different advantage to us. Okay, so that's something that we would really look for. If somebody has, yes, that's a good candidate then. One thing is very important in any profession is that you have to be available to your client all the time. Okay, so like you can say there's some me time there, but when the chips are down, there's no me time. All right, and that part of the story is, I think, common to any work or any businessman who is successful, or any professional who is successful would have gone through this. So like there's been a call like at 12:30 or 1 o'clock in the night. The Phoenix Mills, the entire development. So I remember 12 years ago, the owners called me up, part of my structures collapsed, some people are trapped, I need your help. Now at 1 o'clock in the morning, you're sleeping, you're woken up, that's the type of call you get, that's the commitment level, yeah, okay, I'm coming, give me an hour, I'm there. The permissions, because you got to have, now once you're involved, then you give reports, you got to give designs, you got to get things going fast. And there's no time saying that, I'm going to think about this and things like that. So there is no Sunday, no Saturday, nothing. You're working through 15 days to get that done. And probably you're working till 2 o'clock in the night and getting up again at 6:30 or 7 and starting. So that's the type of commitment that you should be ready to take if you want to be successful in our line. It's not only a 9 to 5 job. We take up jobs which are in middle of nowhere, right? Now, supposing we do a steel plant. There's no 5-star hotel, there's a guest house, okay, there's mosquitoes, food is not great, but that you got to do. You there, do it, come back, design, again go back. So we did the Nhava Sheva International Container Terminal. Don't think it as a 9 to 5 or 9 to 6 job. If you're going to think that in this profession, you're not cut for this profession. You got to be ready to work hard and you got to give it your all. And keep learning. I've got into all parts of civil engineering and design. Without having designed a port, I designed a port. I had never done a port before Nhava Sheva International Container Terminal. And so my client said, he saw our background and said, I'm confident you'll be able to do it. I said, I've never done it. He said, don't worry. And we did it. We did 3 airports. We did 3 ports. So, steel plant. So that is the challenge, and that is the uniqueness of the, profession that you have as a civil engineer. You can do A to Z